Hello, my dear students. Welcome back to CSIR June 2021 free crash course series. Today we can study Michaelis-Menten equation. For CSIR point of view, there won't be any question like derive Michaelis-Menten equation. This is only for understanding. Okay, this one we have studied earlier. That is enzyme plus substrate combines to form enzyme substrate complex. Then it dissociates into product plus enzyme. So here initial velocity, this V0 is equal to initial velocity is equal to K2. K2 is the rate limiting constant. This one. Okay, K2 is the rate constant and this is the rate limiting step. Okay, rate constant of rate limiting step. V0 is equal to K2 into ES. When this V0 becomes Vmax, when the enzyme, the present in the reaction is bound to, all the enzyme present in the reaction is bound to its substrate. That is when this ES equal to ET, V0 becomes Vmax. We can write Vmax is equal to K2 into ET. Instead of ES, we can use ET. E total is equal to free enzyme plus enzyme substrate complex. And how much free enzyme present we can calculate by this equation. EF is equal to ET minus ES. That is, we can subtract from ET, total enzyme minus enzyme substrate complex is equal to free enzyme. We can assume that rate of formation is equal to rate of breakdown. And which is the rate constant for rate of formation? Yeah, K1. So rate of formation is equal to K1 into E into S. This one. And rate of breakdown that we studied already, that ES can dissociate into product and enzyme, and also it can dissociate back into enzyme plus substrate. So two reaction here for breakdown. That is first K minus 1. Here enzyme substrate complex dissociate back into enzyme plus substrate. That is K minus 1 into ES. ES is the substrate here. Reactant here. ES is the reactant. Here plus K2. K2 is the rate constant of product formation. K2 into ES. Then this E, that means free enzyme. And we can substitute this equation here. EF is equal to E total minus ES. We can substitute this one here. Then it became K1 into ET minus ES into S is equal to, we can combine these two. K minus 1 plus K2 into ES. Then we can multiply this one. K1 into ET and K1 into S. And again K1 into ES and K1 into S is equal to K1 plus K2 into ES. Same here. Adding the term K1 ES to both sides of this equation and simplifying, it gives this equation, that is K1 ETS is equal to K1S plus K minus 1 plus K2 into ES. This one is the previous equation that we simplified. And we can solve this equation for ES. ES equal to K1 ET into S divided by K1 into S plus K minus 1 plus K2. And we can simplify further. How? Combining the rate constant into one expression. That is this one. ES equal to ET into S divided by S plus K minus 1 plus K2 divided by K1. And this one we know. What is this? K minus 1 plus K2 divided by K1 is equal to Km. That is Michaelis-Menten constant that we studied. And we can substitute this one into here. So ES equal to ETS divided by Km plus S. we can substitute Km here. And initial velocity is equal to K2 into Es, that you know. And we can substitute this one, that is Es is equal to Ets divided by Km plus S into this equation. And this equation becomes V0 is equal to K2 Ets divided by Km plus S. And you know this equation that we studied, Vmax is equal to K2 into Et. When it becomes Vmax, when this V0 becomes Vmax, when all the enzyme is bound to its substrate, then Es equal to Et. Then V0 becomes Vmax. And we can substitute this one, Vmax here for K2 Et, this one here. So V0 is equal to Vmax S divided by Km plus S. This is Michaelis-Menten equation. Okay, what you have to study? You have to study this one. V0 is equal to Vmax S divided by Km plus S. Then you have to study V0 is equal to K2 ES. Then what you have to study? You have to study the relationship between V0, Vmax, Kcat, Km, etc. If you like this video, please subscribe and share. Thank you.